Welcome back to BAS 121. We're going through Chapter 11 and we're talking about Monte Carlo simulations, and we're going to use the Risk Solver add-in. And so some steps. First, you develop the spreadsheet model, which the example will go through. Then, just like we did in the Excel example, you've got to determine some sort of probability distribution. In order to run a simulation, you've got to determine, well, what are tell the machine, what are the probability, or what is the probability distribution for the uncertain variable? So if the uncertain variable is demand, I got to say, is the probability distribution a normal distribution, a triangular distribution? I have lots of choices. I'm probably going to have to give it the mean or the standard deviation or the high and the low, some sort of variables for my simulation to run on. And then I have to identify the output variables that you want to predict. We'll choose a number of trials. We'll run the simulation, and then we'll interpret the results. So now I'm going to go right into an example that they call building your very first.
In this video, we're going to show how easy it is to add simulation to an Excel model using Risk Solver Platform or Risk Solver Pro to give yourself a much deeper level of insight into the range of potential outcomes for a given situation, the probability of each of those outcomes, and how you can use that information to make better decisions. For this example, let's assume we're a financial analyst or a business manager, and we've been asked to forecast profit for the next year. As with any forecast, there's uncertainty. So the first thing we do is we go to sales to understand their perspective on revenue. And based on uncertainty around the economy, they think that there are three potential sales scenarios. There's a hot market, an okay market, and a slow market. If the market's hot, they think they can sell about 100,000 units at $10 a unit. If it's just okay, it'll be 75,000 units at $9.50. If it's slow, it's 50,000 units at $9.50. In addition, because of the uncertainty around the economy, they think each of these scenarios has about an equal chance of happening, and also that they may be able to push pricing a little bit harder than shown here, but this is their going-in thinking. Next, what we do is we go and talk to manufacturing to understand the cost side of the equation. They come back and say the most likely cost per unit is $6.50, but because of uncertainty around the price of raw materials, it could actually be as low as $5.50 or as high as $7.50. And while we're early enough that we could actually potentially impact fixed costs for next year, their going-in assumption is it'll be about $200,000. Once we have this information, people often start to build what-if models in Excel. And so what I've done is build a small one here where I have a cell to input which sales scenario actually happens. I've used a choose function where, based on the number I put into J4, the sales scenario cell, it'll choose the first, second, or third related volume, E4, E5, or E6, and input it into this cell. And the same thing for the selling price, where it'll choose the G4, G5, or G6, the actual selling price. So for sales scenario 1, it's put in 100,000. For selling price, it put in $10. I can change the sales scenario from 1, 2, or 3 and have the sales volume and selling price automatically update. For unit cost, I made it equal to C10, which is my most likely cost. And for net profit, I put in a formula, which is essentially the sales volume times the difference between the selling price and the unit cost minus fixed costs. At this point, I can now do some basic what-if analysis by changing the actual sales scenario number. You can see with sales scenario 1, we're set to make about $150,000 in profit. If I change that to sales scenario 2, you can see the sales volume and the selling price both drop to reflect the levels associated with that sales scenario, and our profit drops to $25,000. If I choose sales scenario 3, then all of a sudden our profit turns into a loss of $50,000. This is helpful perspective, but I want to get a much deeper level of understanding into the range of potential outcomes, the likelihood of each, and what I can do as a result of that insight to help make and inform better decisions. So let's go ahead and convert this what-if model into a more powerful simulation model. First thing we need to do is capture the uncertainty that we have around which sales scenario is going to occur and what our actual manufacturing costs are going to be. So let's go ahead and let's clear the 3 that I put in manually, and let's put a distribution in that cell instead. Since it's a choice of 1, 2, or 3, it's a discrete distribution. Since sales is said each is equally likely to occur, let's go ahead and make it a uniform distribution. A dialog box pops up. Risk Solver Platform, of course, not knowing what what range we want to put in, pre-populates as 0 through 10. Let's go ahead and replace that with our range, 1 to 3, reflecting each of the different sales scenarios. And we now have a distribution of 3 scenarios, each equally likely to occur. And we can close this. You can see now in our sales scenario cell, we have a psi-int uniform distribution with a range of 1 to 3. If we mouse over the cell, we can see the distribution show in the pop-up, which makes it really easy to see what our model looks like. And for unit cost, we can go ahead and do the same thing. Right now, we're just pointing to the most likely cost, but we know the most likely is 650, and we know the lower bound and the upper bound, but we're not sure of much more beyond that. So probably the best choice for right now is to go ahead and choose a triangle distribution. Rather than entering it this way, as I just did with the sales scenario, because the risk solver platform is so tightly integrated with Excel, let's go ahead and actually just enter the psi function for this distribution right into the Excel cell. So we'll do equals psi. You can see all the psi functions. The reference guide contains a full list of every function and how to use it. Start typing triangular. Automatically narrows our choice. We choose triangular, and we go ahead and pick the lower bound, the most likely, the upper bound, close, and now all of a sudden triangular is showing, and you can see this cool little pop-up which shows our distribution as well as the formula. And that way, if we wanted to edit anything, we could just double click on the box just like we would normally do. You can see how our parameters are referencing cells instead of absolute numbers, and there's some additional options we have to use to set this distribution. One of the things we know we want to do is we want to capture the average profit across all the range of outcomes, but we also want to understand what does that range look like and what can we do to potentially reduce risk in our forecast or have a better forecast. And so let's go ahead and first add an additional cell here, which is called average profit. And what we're going to do here is we're actually going to use this cell to capture across our Monte Carlo simulation trials the average of all our net profit cells. So we do this by first clicking on net profit, since that's what we want an average of. We'll go ahead and use a statistic, and we'll do mean for average. And Resolver Platform is going to ask us, where do we want to put this mean? We'll click right here, and you can see an NA went in because we haven't actually yet run all our trials. There's no average across the trials. And now we're actually ready to run a simulation with, say, 1,000 trials. Before we start, let me show you one thing about Resolver Platform, which is our task pane. In our task pane, you can actually see our model now represented. We have J4, which is our sales scenario, J7, which is our unit cost and our uncertain variables. We actually have J11, which is our mean profit that we've calculated using psi mean, and that is our statistic. And by choosing that as our statistic, we've actually set our uncertain function, our output cell, net profit, in our model as well. And this is going to allow us to actually double-click on that cell and see the range of outcomes. So let's go ahead, and we can see that we're going to run 1,000 trials. We'll go to the output pane. You can see that nothing's been done yet, and we'll click Solve. And in about 0.17 seconds, we ran 1,000 trials. Resolver Platform is so fast that while this is a simple model, you can imagine even as you get more complex, you're going to continue to be able to use it very easily. After running our simulation, we can see our average profit across those trials is about $58,000. Let's go ahead and double-click on our net profit cell. And a dialog box comes up that shows us our profit. We also have set a lower cutoff of 0. And what that is saying is that we have a 59% chance of making a profit and a 41% chance of losing money. And you can see some statistics down here as well. Our minimum is a $100,000 loss. The maximum is about a $300,000 gain. We've got a pretty big range here. And then you could actually scroll down and see some more statistics. And then also you can manipulate the chart. You can see percentiles, the chart type, chart options, change your axis, put some markers in. Very powerful capabilities. In addition, at the top you can see your cumulative frequency, your reverse cumulative frequency. You can see some sensitivity information. This is interesting because what this is telling us is that J4, our sales scenario, has a much bigger impact on our profit or our net profit than J7, which is the actual cost. So if I'm going to have a discussion about how do we either reduce risk or make more money, where am I going to be focusing more on? I'm going to be focusing more on which sales scenario is going to happen, and within that, what the pricing is that we can charge in the volume. So let's go ahead and we'll go back to frequency. And let's close this. Now with this, one of the things you can do is you've run your simulation trials, you can see where your average profit is, you've seen a general distribution of your profit. So we say, okay, well let's go ahead and let's change our selling price because sales said that they had some upside. And instead of $10.50, for example, let's make it $11.50. Let's go ahead and make each of the selling prices. So basically we're going to push the pricing $1 higher. And let's see what happens here. So we can go ahead and rerun the model. 0.19 seconds, and you can now go back. You can see our average profit jumped from about 58,000 to 133,000, and we can open up again. And now we see that our chance for profit is 82%. What's also interesting in looking at a histogram is you get to see the distribution of the profit, and you can see this is the impact of if it's a hot market, you're making a lot of money. If it's less than a hot market, you're making a lot less money, and that's where a lot of your risk is. And now, instead of losing about 98,000 as a minimum in terms of the range of options, we're down to 43, and our maximum is up to about $400,000. By clicking on the Simulate button on the ribbon, you can turn on interactive simulation. And now every time we make a change to the spreadsheet, it's instantly going to rerun our model. So, for example, now what we can do is we can change the OK market from $10.50 to $11, instantly rerun. Same thing, instantly rerun. Now we're actually at a 96% chance of making a profit. In addition, we're far enough out, so maybe our fixed cost instead of $200,000 is actually $125,000. Now that no simulation trials are resulting in a profit less than our lower cutoff of 0, that line disappears from our chart. And again, we can still look at cumulative frequency, reverse frequency, sensitivity. We still see that our sensitivity is more around J4, which is the sales scenario. But we're able to instantly update. Now we can do some really powerful what if this is 9.5, and we get an instant update. So with RiskSolver Pro or RiskSolver Platform, we're able to turn an ordinary Excel what-if model into a powerful simulation tool by changing just a few cells, giving us a much better understanding of the range of potential outcomes that we face and what we can do to manage risk. Of course, RiskSolver Platform and RiskSolver Pro have a host of more advanced features than we've touched on here. Just to give you a taste, for example, instead of individually changing the pricing and running different simulation runs, you can actually change multiple prices concurrently and get a view across multiple simulations, each with 1,000, 5,000, or 10,000 trials. This allows you to more quickly get a broader picture of not only your risk and how to manage it, but a range of options that you can choose to do so. For example, in a hot market, instead of manually typing 1150, I can use our SciSim param function and say I want to actually run multiple simulations, perhaps starting the pricing at $10 and at a low end up to $12 at the high end. For the next one, perhaps let's use a SciSim param again, and we'll narrow this one down to 9 to 11. And for a slow market, let's use a SciSim param, and we'll make this 8 to 10. Now you can see in my task pane, I've actually designated cells G4 to G6, my 3 pricing cells, as parameters. And what I can do now is I can go to Platform, and instead of just running one simulation, I can run, say, 5. Since my range is $2, I could then run 5 simulations starting at the low end, incrementing it 50 cents up until the high end. And now when I go to my output, I can click Run. Instantly runs all 5 simulation runs of 1,000 trials each. And now I can go to charts, for example, multiple simulations. I have a range of choices. I just do a box and whisker. Let's select all 5 simulations, and I'll move them across to be included in the chart. And voila, I can see that with all 3 parameters set to their lowest value, here's my results. and I can go right across. If I want to see more detail, I can just open up the side pane, and I can see right away that my dashed line here is the mean result across that simulation, and the median is shown above, and this is the 75th percentile and the 25th percentile, and I can change those. So I get a lot of good detail very quickly. This is obviously a very quick introduction to this, and there are many more capabilities that RISSolver Pro and RISSolver Platform have that I think you'll really enjoy and you'll find meet your needs and make it very easy for you to identify, understand, and manage risk. While this is clearly a very simple model, you can imagine how easy it would be to scale this model, capture many more business variables, much more uncertainty, and still be able to easily analyze the risk, your options, and inform your decision making.